concentration of an acid or an alkali using a known concentration of acids or an alkali. And in this experiment, you will observe a neutralization reaction. Okay, so to begin with, let's identify the chemicals and apparatus that we are going to use. First is the hydrochloric acid. So we don't know the concentration of this hydrochloric acid, but this is a dilute solution. Dilute meaning to say the concentration is just low. But still, you have to use gloves because it's still corrosive. Okay? Next is sodium hydroxide. In this experiment, we are going to use 1 molar sodium hydroxide. 1 molar means 1 mole of sodium hydroxide per decimeters cube. Okay? Then, phenolphthalein. So, phenolphthalein is the indicator that we are going to use for this experiment. Why not universal indicator? Because universal indicator have different colors like red, orange, yellow, green, blue. So you cannot simply identify whether it's already acid, whether it is neutral, or whether it is alkaline already. But in phenolphthalein, you can see a distinct color because it only has 2 colors. One is colorless, the other one is pink. It's colorless for acid, it's pink for base or alkaline. Okay? Then the apparatus, we need the flask. Make sure you're going to label the flask that you are going to use. Like for example, in here, we put here HCl. So this will be the container of the HCl. This is where the HCl will be put, or the hydrochloric acid. Then, a dropper and small beaker. Why do we have to use a small beaker and a dropper? So that we will just transfer small amount of phenolphthalein on the beaker. Why do we have to transfer small amount of phenolphthalein on the beaker? Because we only need a drop of this, or 2 or 3 drops of phenolphthalein. We are not going to use the whole amount. And imagine if you're going to put this dropper inside the container of this phenolphthalein and we contaminate it, we cannot use it anymore. So we just need a small amount and transfer it here in this small beaker. Okay? The next is the pipette with a bulb. The pipette bulb. In this pipette bulb, you will see 3 letters. One is A, S, and E. A stands for air. Okay, this is where you're going to release the air. The S means suction or suck. Then E is for empty. Later, I'm going to show you how to use this one. The next is the burette. So this burette, it is the container, or this is where we're going to put the sodium hydroxide. Okay, the sodium hydroxide. Earlier, I already put the sodium hydroxide inside. The 1 molar sodium hydroxide. You cannot just simply transfer it above. So what I did was, I put it on the floor and then transfer it using a funnel. So you are not going to transfer it high as this one because it's very dangerous. Now, let's start. So for this one, I just put it here. Then we transfer the hydrochloric acid into the flask. So again, you're going to use the pipette to transfer the hydrochloric acid. Okay, so let's put it here to make it more comfortable for us. So again, put the tip of the pipette liquid with the hydrochloric acid, then press this one. Press the bulb and A. Okay, so as what you can see, it's like this. Now, press S to stop liquid or the hydrochloric acid inside. In this pipette, you will see a blue line. This blue line indicates that it's already 25 ml of the acid. Okay, so let's start. Press S. Now, if you're going to observe, there's a liquid going up here. Okay, if you can see it on the video, the liquid is going up or the acid is going up. So we're going to have it until this level, until that blue line. Okay, now it's until this blue line already. Okay, now we can transfer the exact amount of 25 ml or cm cube of the acid in the flask. Let's press E, transfer it here in the flask until the last drop. So we can say that it is till the last drop. Okay, that's it. Let's put this on the side. Press A. Okay. Next, put this on the side also. Then we put 3 drops. 2 to 3 drops of phenolphthalein. So we're just going to put 3 drops. 1, 2, 3. And let's put this on the side. Then shake it. Okay. As what you can see, it's still colorless. Okay. It's still colorless because it is acid. So the color of phenolphthalein inside is still colorless. Now we are ready for the titration process. Okay. So let's start. For you to put the liquid inside, you just have to twist this. You just have to twist this. It can be clockwise or anti-clockwise. So let's do it clockwise because it is more comfortable for us. So let's do it clockwise. Okay. So as what you can see, once we put the sodium hydroxide here, it's turning pink. Okay. Look again. Look again. Okay, it turns pink, but when we shake it, it becomes colorless. The reason is, if you drop the sodium hydroxide there, some of the part becomes alkaline already or basic already. But when you shake it, when you distribute that, it still turns colorless. It means the sodium hydroxide is still not enough to neutralize the acid. Okay, so let's put some more. Okay, then make sure you shake it. Okay, make sure you're going to shake it. Since it's hard for us to turn this solution into colorless again, it means we are near the neutral substance. We are near to its neutralization. So we just add drop by drop of the sodium hydroxide. So far we are able to use 6 ml of sodium hydroxide already. Now we're just going to do it drop by drop. So once it turns pink, we can say that it is the amount needed to neutralize the acid. So again, it is 6 ml. We just add drop by drop this. Okay. See, it's almost not turning pink anymore. Then we just add 1 more drop. So again, it is 6 ml. 1 more drop. Okay, so that's it. Okay, still not enough. So 1 more drop. This is 6.1. Just 1 drop. Okay, so that's 1 drop. Okay, so it turns like pink already. Okay, but we can say now it's a bit like pink and pink. It's in the middle of the two. Now we can say that the amount we use of sodium hydroxide is 6.1. So 6.1 ml of 1 molar sodium hydroxide is needed to neutralize this acid, which we do not know the concentration. But using equation, which I am going to show you now, we can identify the concentration of this acid. Okay, so wait, and I'm going to show you how to solve this problem in identifying the concentration of this acid.